Mathematical physics is a branch of physics which has more of a focus on mathematics and the mathematical structures that lie behind the physical theories which explain our real world. Given that physics and the laws of physics explain, as far as we can tell, everything that we do observe, mathematical physics is a core part of the natural sciences. Students study a variety of topics in pure and applied mathematics and in physics. This major is ideal for students who want to gain a deeper understanding of the mathematics behind the physical theories which we currently have. Students not only study advanced physical theories such as quantum mechanics, but also the mathematical structures which underpin those theories. The laws of physics underlie and explain everything that we see around us. Consequently, understanding the mathematical theories and structures which underlie those laws will hopefully enable us to make the next generation of discoveries in physics. What students like about this major is that it gives them the opportunity to do a deep dive into the big questions of physics, such as quantum physics, cosmology, and astrophysics. These are all areas of active research within the school, and there are many unanswered questions which we're still trying to attack, such as the nature of dark matter, the Big Bang, and detailed questions in quantum physics.
So at Melbourne Uni we've got the biggest mathematical physics group in the country, probably the biggest in the Southern Hemisphere as far as I'm aware. Very strong researchers, we've got excellent theoretical physicists to complement that, and we also have very strong pure mathematics groups. So really you're getting the best of all possible worlds. This is by far the best place in the country to do mathematical physics. So typically we have maybe 20 students who graduate each year, and I think it's wonderful that the University of Melbourne has the resources to be able to dedicate an entire undergraduate degree. This is, I think, unheard of across the country at present. The mathematical physics major is preparatory. The BSc here is going to get you to the point where you are now prepared to go on and learn the stuff that is the tricks and the trade of a working mathematical physicist. And in that we have advanced coursework leading right up to our third year subjects, of which we have a core which is unmatched across the country. And there are also opportunities to do research projects for credit. So you can take one of your science electives as a research project, and then you can pair up with one of our world-class researchers and see what mathematical physics research is actually all about. So my favourite subject is called Methods of Mathematical Physics. So it's a subject which I've taught a couple of times over the last 2 years, and I'm actually actively involved in redeveloping it at the moment. So it's a subject which is run through the math department, so it teaches mathematics, but uniquely among math subjects it's geared towards physicists. So the idea is that all of the mathematics which is really important for understanding theoretical physics is sort of covered in this subject in a nice way where we build the bridges between the two disciplines. So one of the interesting pieces of feedback that I've gotten from students at the end of the degree is that students come into the degree expecting that the mathematics they learn will be there to support the physics. And one of the interesting things is that they find by the end of the degree that the physics is actually starting to play a role where it supports the mathematics. So what I mean by that is that a lot of the great mathematics of recent times has in fact been driven by physical reasoning. And so in many senses it's physicists and theoretical and mathematical physicists in particular who are coming up with new mathematics which mathematicians can then push into new directions. In a sense, physicists, and I guess this is the role of science in general, can help to shape mathematics by telling them what's actually interesting and what's beautiful. So I said before that mathematical physics is a preparatory degree, but that doesn't mean that the skills you learn can't be transferred directly into industry. The creativity that you gain in a mathematical physics degree and the analytic skills are in high demand across many industries. So in particular, my last PhD student was snapped up by Oracle recently. We have students who are working for patent offices, working for defence, working in, of course, in education. There are many different roles, and I think as a practicing math physicist, you're capable of doing all of these things. You just have to seize the initiative.
One of the exciting things on the horizon at the moment is the oncoming revolution in quantum computing. Students from the mathematical physics major will be ideally placed to contribute this with their deep knowledge both of quantum mechanics and the mathematics which underlies it. The School of Physics is a leader in quantum computing, and students in this major will have the opportunity both to take subjects in quantum computing and learn how to program a quantum computer.